A Russian defensive position can now be threatened before Ukrainian soldiers directly step into the fire zone. On a front watched by UAVs, hunted by FPV drones, and covered by artillery, every movement can become a signal detected from above. A supply road can turn into a trap. A mission to pull wounded troops out can become a race against drones. A position that must be approached can force infantry to pay the price before the battle truly begins. At first, these machines may only carry supplies, move ammunition, or pull wounded soldiers away from danger. But as the war of attrition continues, UGVs are starting to enter more dangerous missions, where direct human action was almost always required before. This is the story of how Ukraine is trying to change the cost of every mission on the battlefield. So what roles is Ukraine giving ground robots first? Why are UGVs shifting from logistics tools into a direct part of combat? And what happens when UAVs above, FPV strike drones, and ground robots below are connected into the same combat chain? Let's find out with military force. Ukraine is moving ground robots from the rear area into the working edge of the battlefield. These machines are no longer limited to carrying boxes or proving new designs in safer zones. They are being pushed toward routes, trenches, tree lines, and damaged settlements where human movement is already under constant pressure. The shift matters because the war has made even simple movement costly. A small team crossing open ground can be seen by a reconnaissance UAV. A vehicle stopping on a road can draw FPV drones within minutes. A rescue group trying to reach a wounded soldier can become another target before the mission is complete. In that environment, Ukraine is looking for tools that can take the first risk before a soldier has to take it. This is why UGVs are spreading across more tasks. Some move ammunition and supplies to forward positions. Others help evacuate wounded troops from places where a normal vehicle would be too visible. Some can scout closer to enemy lines, while others can carry mines, weapons, or small payloads for direct combat work. The same idea runs through all of these missions. Send a machine first when the route is too exposed for a person. Ukraine is not building one universal robot for every task. Rotel H, Term IT, ZMIY, Ardal, and Protector show a wider approach to battlefield robotics. Some platforms are better suited for transport. Others are built for fire support, mine delivery, or movement through rough ground. This variety gives commanders more choices, and it also shows that Ukraine is treating robots as part of a wider combat system shaped by battlefield pressure. The most important change is not the shape of the machine, but the role it plays inside the fight. A ground robot can move beneath reconnaissance UAVs that watch from above. It can deliver supplies while FPV teams cover the route. It can approach a dangerous point while soldiers remain farther back. In this model, UGVs do not replace every human decision, but they help move the most dangerous physical tasks away from exposed infantry. That makes the rise of UGVs a direct response to the conditions of the war. Ukraine is not adopting robots because the technology looks futuristic. It is doing so because drones, artillery, mines, and surveillance have made the front line unforgiving. Every exposed movement can reveal a position, and every delay can invite a strike. But this shift becomes even more serious when these machines are not only supporting the rear, but also helping Ukraine pressure Russian positions without sending infantry directly into the most dangerous ground, under direct fire and constant drone observation now, where the next phase of this story begins. Ukraine's most important robotics claim is not about a machine carrying supplies behind the line. It is about a Russian position that Kyiv says was taken without Ukrainian infantry entering the most dangerous ground first. According to the Ukrainian account, UAVs watched from above while ground robots moved into the area below. That sequence matters because the first contact with danger was shifted away from soldiers. If accurate, the value of the operation is clear. Ukraine avoided casualties in the phase where losses usually begin. A normal assault forces infantry to cross exposed ground, close the distance, and absorb the first response from defenders. Here, the machines carried that first risk, while human operators remained farther back and command teams could observe the fight before deciding whether infantry should move closer. This event should be treated carefully. The position appears to have been a smaller defensive point, not a major fortress or a deep command center. That matters because one limited success does not prove that robots can break a full Russian defense line. It also does not mean infantry is no longer needed. But the size of the position does not erase the tactical signal. New methods in war often begin with narrow tests, not dramatic victories. A tactic becomes important when it survives real conditions, including enemy fire, broken terrain, poor visibility, electronic pressure, and human fear. Once it works once, commanders can study the result and decide where the same method may work again, especially in places where direct movement would normally be too costly. The operation points to a different order of attack. Instead of sending soldiers forward first, Ukraine used aerial eyes and ground machines to shape the fight before human assault teams had to move closer. UAVs could identify trenches, firing points, entrances, and movement inside the position. UGVs could then create pressure from the ground, forcing defenders to react to a machine rather than an advancing soldier. That changes the defender's choices. Shooting at a robot may expose a firing point to drones overhead. Ignoring it may allow the machine to move closer. Pulling back may open the position. Staying in place may leave the defenders trapped between observation from above and pressure from below. This is why the event matters beyond the immediate ground taken. It shows how UAVs and UGVs can work together before infantry appears. The drone provides the view. The robot provides movement and presence. The soldier remains outside the first danger zone for longer than before. The deeper effect is on command thinking. If a commander can test a position with machines before sending soldiers, the cost of the first move changes. A failed attempt may destroy equipment instead of a squad. A successful attempt may weaken a defensive point before infantry closes in. A risky mission may become more acceptable if the opening phase no longer begins with human exposure. This does not make robots a complete answer. They can be stopped by terrain, mines, artillery, enemy drones, technical failure, or loss of control. They still need operators, maintenance, planning, and protection from other systems. But their value lies in changing who takes the earliest and most dangerous contact. That is why this reported capture should be read as a precedent. It does not prove that robots can win the war alone. It shows that Ukraine can use machines to pressure a position before soldiers enter the most exposed space. Once that lesson has appeared on the battlefield, the next question becomes bigger. It is no longer whether Kyiv is testing ground robots. It is how far Ukraine is preparing to scale them across more units, more missions, and more dangerous sectors of the front in the months ahead now. That pressure points toward wider robot use across Ukraine's front. Ukraine's plan to contract 25,000 ground robots in the first half of 2026 marks a turn from battlefield testing to organized military procurement. Defense News reported that the target is more than double the number bought in all of 2025. It also reported that contracts for 2027 had already begun, giving manufacturers a longer pipeline instead of one short wartime order. That difference matters because armies do not plan around tools that arrive only in small batches. They plan around equipment that can be ordered, delivered, repaired, and replaced. At this level, UGVs begin to look less like rare experimental vehicles and more like a category of frontline equipment. Kyiv is signaling that ground robotics should become predictable enough for commanders to request them, train with them, and expect replacements when machines are lost. This is how a new tool moves from demonstration to doctrine. The scale also shows how Ukraine is trying to organize its defense industry under pressure. Kyiv is not waiting for one perfect foreign robot to solve every battlefield problem. Reuters reported in 2025 that Ukraine was preparing robotic vehicle units after trials with soldiers, which shows that the military was already building structures around these systems before the 2026 contract push. That approach fits Ukraine's wartime reality. The front changes too quickly for a slow procurement model. Different units need different machines, and developers must respond to terrain, operator feedback, payload limits, control problems, and enemy adaptation. A robot that works on one road may fail in mud, rubble, or thick vegetation. A model that succeeds in transport may need redesign before it can support another task. This is where Ukraine's domestic robotics ecosystem becomes important. Smaller manufacturers can adjust designs faster than large traditional programs. A weak track, short battery life, poor signal range, or difficult control layout can be identified by operators and sent back as a practical problem, not a theory. Engineers can then change the design and return a new version to the field. That cycle gives Ukraine a form of speed that is not measured only in factory numbers. It is measured in how quickly lessons become hardware. Better batteries can add distance. Stronger frames can carry heavier loads. Easier controls can reduce operator stress. Modular designs can help units adapt one platform for several battlefield conditions. In a long war, these small changes can decide whether a machine is useful or ignored. The 25,000 figure also carries a political message. It tells soldiers that Kyiv is trying to reduce the burden placed on exposed manpower. It tells manufacturers that demand may continue, which encourages investment in production lines and spare parts. It tells foreign partners that Ukraine is not only asking for technology, but also building a national base for unmanned systems. Still, procurement numbers do not guarantee battlefield success. A large robotic fleet needs trained crews, repair teams, secure control methods, transport capacity, batteries, spare components, and clear rules for use. If these support layers fall behind, many machines can become idle equipment instead of combat value. That is why the coming test is not simply whether Ukraine signs enough contracts. The real test is whether the procurement system, training base, and repair network can grow together. If they do, UGVs may become part of routine unit planning rather than an emergency tool. And once production reaches that point, the next question becomes whether these machines are already appearing often enough in real operations to change the daily rhythm of the front across different brigades and sectors. The most revealing sign of Ukraine's ground robot campaign may not be the size of one machine, but the rhythm of its missions. Ukrainian officials have reported more than 22,000 UGV missions across 3 months, with more than 9,000 in March alone. These figures should be handled carefully because they come mainly from Ukraine, yet they still point to a serious trend. Robots are no longer appearing only in rare battlefield clips. They are being used often enough to enter the daily tempo of operations. That tempo matters because war changes through repeated routines, not only through dramatic moments. If a robot carries ammunition once, it proves a basic concept. If robots move supplies, help evacuate wounded troops, deliver mines, and support forward positions thousands of times in a quarter, they begin to shape how units plan each day. Commanders can consider when to send a machine, which route it should take, how long the movement may last, and what danger remains for soldiers who stay farther back. This is the deeper meaning of the mission numbers. They suggest that UGVs are entering the normal workflow of Ukrainian units. Some tasks are simple but dangerous, which makes them ideal for machines. A short ammunition run can keep a position alive. Reaching a wounded soldier can save trained manpower. Moving mines into place can slow an enemy approach before direct contact begins. None of these actions alone changes the whole war, but repeated daily use can change how the front is managed. At the same time, the numbers should not be treated as a perfect independent audit. They do not tell us how many missions succeeded, failed, or produced only limited results. A mission can mean many things, from a short supply run to a difficult movement close to enemy fire. That is why these figures are best read as evidence of scale and momentum, not as a final scorecard. Even with that caution, the pattern is important. A system that performs thousands of tasks begins to teach the army around it. Soldiers learn which machines are reliable. Repair teams learn which parts fail first. Operators learn which roads are too muddy, too exposed, or too difficult to control. Commanders learn when a robot saves time and when it creates another burden. This practical knowledge cannot be built in a laboratory. It comes from repeated use under pressure. The result is a quieter but serious shift in battlefield management. Ukraine is learning how to schedule robots, protect them, recover them, and assign them to missions where they create the most value. Over time, that can influence how a unit holds a position, restores supplies, removes casualties, and prepares its next move. Once robot missions become routine, the next step is tighter integration with the systems above them. Ground movement must be linked with aerial observation, FPV coverage, and fast command decisions. A robot that moves alone is useful, but a robot moving inside a wider sensor and strike network can become far more important. That is where the story begins to move from mission numbers to combined drone warfare, and it leads directly to the question of how Ukraine is connecting the ground layer with the air layer across sectors that face different terrain and different enemy pressure daily. Ratel H shows how Ukraine is starting to connect ground robots with flying drones inside one battlefield method. It is not only an unmanned vehicle moving supplies through dangerous routes. Its more important role is that it can carry and launch FPV drones from positions closer to the front, while the operator stays farther back. This changes what a UGV can mean in combat. The machine becomes a mobile launch point that can move through ground too risky for a human team. In drone warfare, the launch location matters almost as much as the drone itself. If the operator must move too close, the mission becomes dangerous before the strike even begins. Ratel H helps shift that exposure from people to the machine. It also gives commanders more flexible timing. A drone can be launched from a forward robotic platform only when conditions create the right opening. It gives Ukraine options when front routes become too dangerous. The fiber optic FPV is the key part of this combination. A radio-controlled drone depends on a wireless signal, and that signal can be attacked by electronic warfare. If the link is jammed, the drone may lose control, miss the target, or fall before impact. Russia has invested heavily in this kind of defense because it has been one of the main ways to fight small drones. Fiber optic control changes that problem. The drone receives commands through a physical cable instead of a normal radio link. That does not make it impossible to stop, because terrain, cable limits, weather, damage, and enemy fire still matter. But it makes standard jamming far less useful. In simple terms, the defender cannot block a radio signal if the drone is not depending on one in the usual way. This forces Russian units to rely more on physical destruction, detection, camouflage, and movement discipline instead of electronic disruption alone. This is why Ratel H is more than a technical upgrade. It points to a tactical pairing between the ground layer and the air layer. The UGV moves the launch point closer to the target area. The FPV carries the final strike through the air. The human team can stay farther from the danger while still affecting the battlefield. For Russian units, this adds another problem to an already crowded battle space. A defender may be watched by a UAV above, threatened by an FPV strike, and pressured by a ground robot moving closer below. Each layer demands a different response. The more these systems overlap, the harder it becomes to rely on one countermeasure. Ratel H therefore shows a wider direction in Ukraine's adaptation. The future is not one robot replacing one soldier in a simple trade. It is a network of machines taking over the most exposed steps of a mission. But behind this technology, the deeper purpose remains simple. Fewer Ukrainian soldiers should have to enter the deadliest ground first. The deepest value of Ukraine's UGV program is risk control. Near the front, artillery, reconnaissance, UAVs, FPV drones, mines, and direct fire can turn a short movement into a dangerous mission. A soldier crossing that space is not only moving through terrain, he is entering a watched zone where one mistake can bring a strike. This is why ground robots matter even when they are slow, imperfect, or vulnerable. They can carry ammunition to a firing position that cannot wait for a safer route. They can deliver water, batteries, medical supplies, or small loads to troops who would otherwise need another exposed run. They can help pull wounded men away from areas where a rescue team might become the next target. They can also place mines or approach a target before infantry has to move closer. Ukraine is not using UGVs because machines are flawless. It is using them because soldiers are limited, trained, and costly to lose. In a long war of attrition, every surviving infantryman matters. A destroyed robot creates a repair and procurement problem. A lost soldier creates a tactical loss, a family tragedy, and deeper pressure on the state. This logic makes every small robotic mission part of a larger manpower strategy, especially when both sides are trying to hold ground under constant drone pressure. The calculation is especially important because danger now extends beyond the trench itself. It covers the roads leading forward, the paths between tree lines, the broken tracks used for supply, and the small openings where wounded troops wait for evacuation. These are the places where UGVs can reduce the number of times humans must expose themselves. Still, ground robots cannot replace infantry completely. Batteries run down, tracks break, mud can trap them. Signals can fail. Russian drones and artillery can destroy them. Some missions still require human judgment, close coordination, and physical control of ground after the machine has done its part. That is why UGVs should be understood as a risk-reducing layer, not a miracle solution. Their purpose is to move part of the burden away from exposed troops and place it onto equipment that can be repaired, replaced, and sent back again. This does not remove danger from the front. It changes who meets the danger first. And that leads to the larger question. How far can Ukraine turn manpower pressure into a new model of modern war? Ukraine's ground robot push shows how a manpower problem can become a driver of battlefield change. Kyiv is not removing soldiers from war, but it is trying to move them farther from the first and most dangerous contact. The emerging model is clear. Humans command from safer positions. UAVs watch the battlefield. FPV drones strike selected targets, and UGVs cross the ground where movement is most exposed. This does not make infantry obsolete. Soldiers will still be needed to hold terrain, make decisions, and control the final result. But robots can change the cost of reaching that point. They can carry supplies, evacuate wounded troops, place mines, support small positions, and help prepare limited attacks. If this trend continues, Ukraine may help define a new standard of modern war. Advantage will belong not only to the army with more people, but to the army that protects them better under fire. Before leaving, make sure to like, share, and subscribe to Military Force for more clear analysis on the weapons, battles, and political decisions shaping today's world. Understanding war is not about celebrating destruction, but about learning how fast human lives can be changed by technology, strategy, and leadership choices. The more people understand the real cost of war, the stronger the public demand for peace, responsibility, and better decisions becomes.